take you up to lunchtime. So the first theme that I'd like to talk about is time, and I've been thinking about the way that we use big data, the way that business moves information around particularly, and how maybe we're moving to much more of a consumer-led speed of the way information flows around a business. And it seems pretty crazy when you think about the way that we do things like annual reporting. The Earth goes around the sun, so let's produce an annual report. The monthly reporting schedule that we're in was a couple of thousand years old almost. So it seems pretty crazy that many of the things we use to make really fundamental decisions at a business level are determined by something really quite archaic. I like the Druid bit the best, really, in terms of seasonal reporting and so on. But customers want something a lot more now. So what we're going to be talking about is some examples that illustrate that I'm pretty sure in my role in the industrial and automotive solutions team in IBM, that we're seeing this mass awareness of internet-connected devices. Not everyone has got things, much more than a smartphone just yet, but the mass adoption of internet-connected devices and technology is absolutely imminent, and I mean beyond the smartphone. And the examples that I'm going to be using are largely automotive, because they're a pretty good example of an industry that's moving at an incredibly fast pace. This is a little screenshot of Google search interest, and as you can see, big data has been going up for the last few years, and Internet of Things isn't actually far behind. So what we're seeing is a great deal more interest in terms of people talking to IBM about how they can connect up devices. And referring back to the time slide, the whole concept was, can we do a little bit better matching customers' expectations? Part of the barrier has been this glass circle represented by the solid white circle, which is really trying to illustrate here that in the past we've dealt with data within the company, and we've been pretty well limited by technology of what we can do with that, but we're now trying to make use of data that's way outside that. And the technology has allowed companies to punch through a glass circle, a glass ceiling if you like, to be able to access and now process and exploit data that's way outside the company's control. And this is the examples I'm going to be giving you are from things like machines like cars, because they're a pretty easy example for us to understand. We all drive, not sure if we're all in that industry, but it's a pretty good example of something that dramatic is changing. And this shift, the biggest shift that I'm seeing in big data technology usage is in the approach that used to be based on understanding a business problem, designing a set of reports, a schema, a data collection process, identifying where the data was, and building backwards into a data warehouse, taking about a year to do that. What we're now talking about is the ability to analyze data in flight, in real time, to some business effect. And examples of this include things like phone tapping, which is pretty mature now, email reading by machines to look for terrorist and criminal activity, and some industrial uses. When we look at why industries are adopting this kind of speed change, partly it's regulatory. So in the automotive industry, there's a thing called e-call coming out. This is a new set of laws across Europe put in place because there are 20,000 deaths or serious injuries in Europe every year where, in terms of car accidents, and the whole concept was to say if across Europe we can put in place a technology platform that will report an accident as it happens, an airbag deployment, and then send medical staff, alert the police or the other emergency services, and open up a phone connection to the vehicles involved, so a call center can actually say, are you okay, what do we need to do to help you, rather than waiting for them to ring. It's going to save a lot of lives, to Europe's benefit. So complying with regulation in terms of connecting devices such as cars is happening anyway. From January the 1st next year, all new cars have to have it. Certain brands of car already have this stuff fitted, and this is technology that's already been matured in the US. I'm going to run through some examples of what that does. The other key point I see is sophisticated consumers. People are going to be choosing devices because of their connectivity. Personal example, my boiler is connected up to the internet, so I can change my heating controls, water temperature and so on over the web, on my smartphone or on an iPad app, and that's paid for itself in the 6 months or so I've had that. And I'm kind of used to the idea that I can now control things that I own to my own personal benefit over the web. And I think as the number of people who use things like Hive and Nest and so on begins to grow, you're going to have a wider perception that actually I'm not going to buy anything to do with technology, including a car, unless it's actually pretty cleverly connected. And that gives an enormous market. So an example of what this thing looks like, this is an aerial view at the top of a road, and it's a curved road, so the cars approaching the red astic circles on the top left-hand corner are going around a corner at some speed, and they're approaching an incident. And the whole point was that we can recognize that now in real time. Now, the car is actually pretty neat at this because it can look round corners. The rules that we've tried to screenshot here in the bottom left-hand corner are basically statistical rules that gather data from vehicles. And bit by bit, it builds up a scenario that says, give me the location of a car where 3 wheels spin at different speeds, because that indicates slippery. And that slipperiness could be caused by ice, which could be validated by the temperature sensor, or it could actually be something like an oil spill, which is just going to happen very quickly and create a hazard. So what we're now able to do is create an alert. So the phase 1 of the kind of car that you'll be getting in the future, in fact now, cars that already do this, will just give you an alert to say, round the corner, there's a problem. And it's asking the human being to lift the right foot off the accelerator, because there's no point driving really fast up to it, then braking. Now, assisted driving cars are the next generation, and these will do it for you. So however hard you press on the accelerator, the car knows better, and it will not put petrol in the engine. It will be easing off. Third generation, things like the Google self-driving cars and so on, these cars are being tested. They're available by 2017, and they will do it all for you. Business benefits, pretty simple, save 30% of the fuel if you don't drive at speed up to something that you have to stop at. So 30% better fuel economy. That's again supported by European mandates and actually the consumer who wants to save money. So these things are going to be happening. The example we've got here is pretty sophisticated, because if you approach an incident directly, it'll give you an alert or some action, and if you turn away from it, then the alert turns off. So we're already pretty sophisticated. Now this is based on real-time cars that could be moving at 80 miles an hour, and there are millions of them. And so far in stress testing, we found that we can support on one server the messaging to support 1 million vehicles. So the stuff we know scales in real time. When you look at the kind of architecture that we're putting in place to support cars, it's actually pretty similar to most of the big data conventional architectures, but with a couple of twists. The stuff that we do on the car itself, using things like MQTT instead of MQ, so the messages, the protocols of sending data around are much more efficient. They use less bandwidth, which costs less, and it's faster. It uses less electricity for battery-connected devices, and it's basically much more efficient, to the tune of about 4 or 5 times over HTTP, which is a great web protocol, but not a great messaging protocol for building real-time big data systems. We then start building analytics, and the big blob in the middle, which has got some little eyes on it, indicate the indicators, the operators. In the previous slide, you saw the PowerPoint slide of all those little rules building up to alert cars of approaching slippery. So this is where the real-time analytics that's been built in a statistical interface, SPSS typically in IBM, R as an open source equivalent, would be the control to build real-time analytics. At that point, we're putting it into visualization or some kind of action-oriented interface, typically back in the car. So many of the arrows that are showing a stream of data left to right are actually two-way. And then we're going into the more traditional things, like putting it into in-memory advanced performance data warehouses, such as the Pure Data System, and then to Hadoop for longer-term storage. Now, the problems that Hadoop is addressing are this kind of problem. This is a Ford Fusion, so it's a mainstream car for sale now, and it's generating 433 megabytes a minute. 433 megabytes a minute is actually quite a bit of data, so we've got some architectural problems to solve to be able to manage that data, and the approach we're taking has been to try and process as much as we can in the car before we actually move it off even to becoming a data stream where we run further analytics. So first generation was, let's take all of the data off the vehicle and stick it in Hadoop and then do some analytics and some statistical processing of it to redesign the architecture. But companies with cars for sale right now, like Tesla, are pretty advanced on this, have minimized the amount of data being sent because they know exactly what data they actually want. The automotive industry is growing its number of connected nodes at a pretty high rate. So this is fairly typical of an industry that's about to go through a massive revolution. So from example of being very product-centric as a manufacturer to being very customer-centric and increasing the connectivity with its end customers. The only one that really beats it is utilities. And that's not about data volume, that's about connected endpoints. So the number of houses where you'll have an internet connection to the boiler, security systems, all those things is clearly an astronomical number and very, very high growth, but the data volumes are particularly small. The problem in the sector I'm focused on, automotive, is we've got both. We've got very large data volumes and we've got a very high number of connectivity points. So this is the sweet spot for very complex big data projects. These are examples that are current of major projects that we're actually working on. And I'm just going to walk you through some examples of these scenarios. The one at the top, to do with product development and engineering, is with BMW. And this is the case where I'm sure you're all familiar with BMW's products. They have 3 Series, 5 Series, and so on, a series of different cars. But they also have something called a pre-series. And this is a test bed for components, for assemblies, and then for final vehicle configurations that are on market. And the problem that we have here is that they may have some common components. For example, a steering column that is in a 1 Series would be the same as a 5 Series, but the stress and workload that they're put upon those components is going to be completely different, a small sports car or a heavy 4x4. So what we have to do is take all of the data from common components and correlate it back to patterns about the usage. So this is basically a problem that BMW have had for many years, and it's generally taken between 2 and 3 months to look at the data from their test bed of vehicles and work out really what is actually working at an assembly and a component level. And that's now possible in real time. Real time from a 3 month time lag in the development of a vehicle is a significant point. So what we're enabling here is time to market for very complex products. 15,000 components in a car, 3 months shaved off the delivery time of a new product through its testing. That's pretty significant from a business perspective. Doesn't matter what industry you're in, if you can get products to market faster, that's going to make some money. When you look at marketing and sales, we're looking at customer data, and a couple of examples we've got here with Fiat is they're very keen to capitalize on their brand at the moment. The little Fiat 500 sales, absolutely fantastic, very trendy little car, but they've had quite an install base, and the problem now is how do they retain their customers? So what we're doing is analyzing anything we can find to do with customer sentiment. Are people likely to buy another one or upgrade to another Fiat car? And can we capture the data and create an action plan to enable that? The results of that program so far, through analysing data and sentiment, have increased customer loyalty by 7%. So that's a pretty significant amount of money these guys are getting from customers who otherwise they would have left. When you look at Mercedes, these guys are very keen to harvest leads. The shortage in the industry at the moment, the automotive industry, is sales leads. Selling cars is the problem. You know, the economy's a little peculiar in the world at the moment, so actually selling cars is their biggest business problem. What we've managed to do so far is generate about 2,500 leads per month for the E-Class Mercedes by harvesting social media data and looking for propensity to buy, and then marrying it together with a customer database, so an incredible matching engine to correlate Toby Woolfe's Twitter address when I'm tweeting, what do you think of the difference between an E320 and a BMW X5, for example, and turn that into an actionable lead to allow the sales force in that company to identify me, connect with me, and make an offer. And that's a pretty significant number of leads. We think if that system goes completely global, it'll probably be generating about 10,000 leads per month globally for that single brand of car, that single class of car. So that's an incredible lead gen engine that completely replaces the idea that people used to you walk into a showroom and ask for a brochure, and that was the salesman's opportunity to capture my details. We're completely going the other way around and going social media mad on this one. When you look at some of the examples of after-sales work, there's a lot of publicity General Motors are getting at the moment, not all positive. They have a bit of a problem with one of the locks that they fit across their platform of vehicles, and the problem is that if you hit a bump, your knee might go up and might turn the lock off. And it has a couple of unfortunate effects. One is it shuts down the hydraulics that power your steering and your brakes. So it's now much harder to drive the vehicle, but unfortunately it's also switched off the airbag. So if you do doink the thing, the airbag's not going to go off. 12 people have died in the US because of this particular fault, and there's about 300 more cases that they suspect are attributable to it. So General Motors have taken a $35 million hit, the biggest fine that the Senate are allowed to give a company in that sector, and a $7,000 a day fine until they resolve the issue. The issue is pretty simple. Identify the people who have the vehicles affected, get it fixed. And until you do, we're going to take money from you. Problem is, you might have bought that car 5 years ago from a dealer. The dealer probably reported back to General Motors brand, whatever it was, your name and address as the owner of the vehicle, but things change. So GM's problem is identifying who owns the cars now and correlating with that data the exact batch of locks that they want to change and then effecting a recall. This is a very expensive problem to have, and it was completely masked because the data is incredibly disparate. When you look at connected vehicles, perhaps the sexier end of the industry at the moment, We've got some examples here of the way that when your car is completely connected to the web as a terminal with wheels, rather than a freestanding bit of engineering. In my opinion, the leading thought leaders in Europe right now are Peugeot, Citroën. So these guys have got to comply with the eCall mandate by January the 1st, but what they've put in place as of today, the beginning of June actually, is data collection capabilities. I'm just going to show you a little bit of a case study. This is published by Peugeot and Citroën IBM marketing office, and I've highlighted the bits that I think are most important. What they've done is create a new business service unit. And the mission number one for this business service unit from June the 1st this year is to put in place a connectivity device in the car that streams data on its usage back to a base station. And that business unit's been formed to capture and store that data. They use the IBM reference architecture and all our technology to achieve that. And then job number two, once they've actually started accruing data, is to create business services around that. And they're being pretty cagey about the business services that they're going to release because they want competitive advantage. They know that once they start releasing these virtual data-based services to customers, the chances are people will start choosing their cars over others because they are serviced better. And examples of the sort of things that they are going public on is this extraordinary thing about collecting weather data. And the first time I heard the idea of building up a database of windscreen wiper movements and temperatures struck me as a little bit odd for a car company. But when you factor in the idea that the Met Office in the UK have 200 automatic weather stations, and these guys are going to have about 800,000 portable weather collecting machines on the roads by Christmas, you can see now that they're going to get about 30 times the data density that the Met Office do. So that data will be sold to the Met Office and others, anyone else who are interested. But also, maybe if you're in a Citroën, you're going to start getting alerts from the cars in front of you, warning you of icy patches on the road or heavy rain. And the idea is, well, actually, there are suspension changes that could make your car safer in heavier rain. So let's have the car adapt as an assisted driving experience to make it safer. So you're going to end up with people selling cars to you on the basis of safer, faster, more efficient, and so on, but much more around data. And so far, most of the focus has been on infotainment, getting it so your favorite radio stations and the seat settings follow you around. But actually, there's a lot more to it in terms of economy and safety of the vehicles. So there's some examples of what these guys are doing, Peugeot, Citroën. Insure the Box are taking another angle. This is a fairly small firm who use IBM for very advanced analytics. We put all of this driver usage data from a dongle from their customers into a database and then process it to run some rules and offers. And the offers are pretty good. So the target market for Insure the Box was people who find insurance too expensive. So the 18-year-old guy in his first car was going to find fully comp insurance costing probably £2,500. So they can sell them a policy at maybe 8,000 miles worth of driving for £1,000, but they have to put the dongle in the car. Now, supposing the 18-year-old actually needs to drive 10,000 miles a year, that's exactly where this analytics come to play, because Insure the Box now make offers to the users of this system to say, well, we've noticed that your G-force has been low, you're never driving after 10 p.m., you're not driving in accident black spots. Those things equal safe driving behavior, which we want to reward, so we're going to offer you this month an extra 250 miles. So someone who buys 8,000 miles worth of miles is going to, if they drive correctly at the rate the insurer wants, they're going to find that they can actually get their full year's worth of driving covered. And that's a pretty significant incentive to change the behavior of a customer base. For the insurer, it means lower accident rates. For the customer, it means affordability. And these guys have trebled the size of their business thanks to that bit of maths. The data set involved is clearly collecting a ton of data off a dongle on a car. That's pretty impressive. The case for Honda, these guys are very, very keen to promote electric cars. And the problem with electric cars is things like range. You don't know whether you're going to make it. So the work that we've been doing with Honda has been to gather data on the use of the battery, the engineering, the driving style, and so on, and combine it all to come up with a very, very accurate model about the range of the car. While we were doing that with them, we found that there was incredible predictability in the data that we were taking off the car. So the figures that stick in my mind are 96% accuracy, with 1% false positives, so the data is accurate. What we're able to do is predict any warranty claim 60 days in advance of it happening. 60 days, that's 2 months ahead. the car will know, or Honda will know, that the car is going to get some sort of warranty claim on it before you do, before you really suffer any knowledge of what's going to go wrong. So that's going to change the relationship a Honda driver has with the company who made it. So at the moment, you could walk into a Honda dealer, give them some cash, drive away. You might see them for a service every year as the Earth's gone around the sun again, so you better take it back. Or maybe 3 or 4 years' time, you're happy and you go back and buy another one. Now, if these guys know how your car is working to that level of accuracy, the relationship is going to change completely. And the use case that I think blew me away the most significantly was that you could take a call from Honda who'd be saying, hey, this is your 4-month courtesy call, sir. Are you happy with the car? Yes, I am. Great. Well, we have some comments on the way you're driving it. You're frequently going into the 4,000 and 5,000 RPM band. You're driving in some very hilly terrain, maybe you live in the Alps or something, but we can see that you've never used the back seats. You've bought a 4-seat car, a 5-seat car, but you've only ever used the front 2 seats. When you click the safety belt in, it tells the car, doesn't it? So we know how the car is being used. Also, we can see that you're spending £300 a month on the finance for this car. How about we give you a car that's perhaps slightly better suited to your needs? It's the 2-seat or mini back seats, one with a 2.5-litre engine that you won't have to gun so hard to get where you're going. It's a new model, and we can trade in your old one, put the new one on your drive in a week for an extra £30 a month. Would you like that sort of offer, sir? So we can see that the relationship between Honda sales, who are short of leads, as all the car industry is, and their knowledge of the way people use their products that they've never had before in reality, is going to change the way that the relationship between a consumer and a complex machine like a car is really about to change. There was another project we did for Honda, which was pretty interesting. This was about robot data. So this is an incredibly efficient manufacturer. They have production lines where the parts arrive, the welding happens, and then the machine, the finished product comes off the other line with almost no waste. It's very, very efficient. But the problem is they get unplanned downtime. So the research project we did with Honda was to take the data off their robots and look for patterns. And the patterns, again, we're seeing hidden in this mass of data, lots of it, are pretty good for predictive analytics. And the example we have here is that we have now 80% accuracy of prediction of unplanned downtime 8 hours ahead. So about a working day on complex machines like robots. And that allows Honda to go fix the machines that otherwise would have stopped a production line. This affects the entire supply chain of their business, which is complex enough already. So there's some good business benefit there. Chevrolet, the example there in the US, this is the way things are going to be in the future. So this is treating a car a bit like a mobile PC. Chevrolet have a car called a Silverado. It's an American sort of SUV truck thing. And the problem that we had in this one that we detected through looking for patterns on the usage of the car was that occasionally the engine catches fire. Now this happens in the case of idling the engine in low temperatures, because the cooling fans would think, well, I'm idling and it's cool, therefore I don't need to keep a cooling fan on, but the engine was actually overheating. So this was detected by looking at the pattern of data on the usage of a vehicle across a very large fleet, 300,000 vehicles, and then figuring out what we need to do about it, which in this case was a software patch using IBM Rational's software management system, which was then downloaded through, oddly enough, the rearview mirror. The rearview mirror in that car carries a SIM chip, a mobile phone effectively connected to the CAN, the car's local area network. So the patch was downloaded to customers by the tens of thousands without anyone having to do anything physical. And the cost of a recall, apart from the inconvenience to a customer, is significant. Maybe it's a couple of £100 per car. So we're now able to automate that process and keep the software on the vehicle working efficiently. So there's a massive financial saving involved in that kind of initiative. The biggest project we've got in my little world of the automobile and complex engineering world for big data is this one. This is a massive data warehousing refresh for General Motors. And the problem here was driven by this regulatory problem that Mary Barra, the CEO, was sitting in front of the US Senate saying, yes, sir, I will get you a list of customers and we will fix that problem of the lots. There are other recalls going on. In fact, they did 13 million car recalls this year, which is more than they actually make. So the logistical problem of identifying which car needs to be recalled for which problem, unfortunately, hadn't been the original design premise of the data warehouse that they commissioned a few years ago. And this has been fixed by bringing all kinds of data into a Hadoop landing zone and trying to marry it together with the masters, the key, the master data, if you like, that identify customers, vehicles, and so on, some of which was in the data warehouse and a lot wasn't. So we've had a lot of work to do very quickly on that one. But you can now see that this system is supporting 329,000 users, got a petabyte in it, and it's based on IBM's Hadoop distribution. So a pretty cheap way of building out very large data storage. So that's a pretty good example of a business-driven upgrade or a modernization of an existing very large data warehousing project. Of course, I'm just talking about automotive and related industries, and I'm sure you know through this conference that there are plenty of other uses. My favorites are things like fraud prevention, simply because it's the biggest bang for the buck. If you've got any propensity to fraud in your industry, then that's a really good one to look for. Example in the automotive world was the budget that's given to the company to satisfy customers who are distressed. In a project, we looked at the use of that budget and correlated it to the HR payroll database, and we found that 20 million euros a year was being used of goodwill budget by the staff, who had found that they could ring up a helpline, complain, and get a bit of money to get their car serviced. So we can find fraud in all sorts of ways, and it's a very good thing to hunt for if you're looking to justify a big data project. And in terms of health and life sciences, I flagged that simply because IBM's placing a big bet on that one, and I think it's a really interesting thing we can do in terms of saving lives. It puts us on the moral high ground, but it also tests our maths and our end-to-end architectures perhaps better than any other industry. Watson has been mentioned a couple of times, and a good example of this sort of thing that it's going to address is what happens. Question, when does 4 by 4, 4 times 4 not equal 16? The answer's in the question, when it's a 4 by 4. And in the automotive industry, you're going to have all sorts of jargon and terminology that needs to be machine understood for this new era of cognitive computing to actually make sense to anyone. But this is live, it's happening now, this is smart computing. You might remember back in 2011 when we launched this thing, we won a game show called Jeopardy, and it's part of the same team who put up Blue Gene, a smart computer, up against Garry Kasparov to prove that a machine could play chess better than a human being. Now we're able to win against some pretty intelligent people's ability to have general knowledge recall in context. And now we're trying to commercialize this thing. What we're finding is that we can actually understand customers pretty well. We can engage with them. The machine can be trusted, and most of all, it operates at speed because it doesn't sleep. But to make this kind of stuff work, if you're thinking about, well, cognitive seems a long way away for your company, all I'd say is that if you called us up now and said we want to buy one of these systems, our first thought would be to say, yeah, we'll ship one in a couple of years, maybe by the time we've got your data ready. So the first phase of the move for most companies to cognitive is to begin to manage your big data assets in a way that will allow innovative new technology to exploit it in the future. Maybe it won't take a couple of years, internet years perhaps. So this slide is know me, engage me, empower me, and this kind of thing is brought to life perhaps better through looking at use cases, which we kind of invent as we go along in each industry because this thing is moving so fast. But a good couple of examples would be asking your car what tyre pressures should be. Who actually remembers the tyre pressure for your car that you're supposed to check every week? Well, it's the kind of thing that the car should be able to give you a pretty simple one-button push answer to, but that can extend into pretty intelligent service and repair scheduling. So again, why should you change the oil in your car because the Earth has gone round the sun once? It is, a ridiculous premise. So many cars actually have some attempt to look at the usage of the car to then schedule maintenance in a way that keeps the car operating better, but it was pretty primitive technology under the covers, and we're now looking at pretty advanced science to make sure that components are changed and maintenance is done, consumables are put in at the right time and place. And we're certainly seeing a shift in the commercial fleet market, where the difference between getting your price right on the buyback of a commercial vehicle, a lorry that might have done a couple of million miles, and it's not all about the mileage on a commercial vehicle, it's all about the hours the gearbox has been spinning and the strain put on the engine, a whole lot of other strange factors that create a true value of the vehicle. So these are things that can be done far smarter by this kind of machine. To enable this, we're talking about putting in a big data platform. So this is partly a marketing slide for IBM products, but the main concept is that the data platform has to be able to take pretty well any kind of data that exists now or is going to be thrown in the future, has to have some kind of governance on it. We sort of say, let's put all your data in one place. If I'm a data thief, where am I going to go? The place where all the data is. So governance is even more critical in a big data world than it is in the lockdown relational database world. On top of that, we're putting various different capabilities like Hadoop for storage at a low cost, stream computing to create that real-time interaction that customers expect, and some kind of high-performance warehousing, typically using in-memory technology, the advances of the FPGA, the in-memory chips that can cope with very large data sets, and real-time analytics. And then on top of that, a layer that is really all about building applications. Once your data layer is established, can you then reuse the data all the way through the life cycle of the product, through CAD design in an engineering term, to its actual usage and the interaction you have with the customer. And if you can get all of that joined together, then you're going to be able to change the way that you run your business, such as Peugeot, who are building this division based on these products in this sort of configuration, pretty well straight out of our textbook. So nice to be able to do business with customers who kind of use us for integration as well as the product functionality. In terms of adoption, there's plenty of things we can do to help, but the first one I think is around just helping educate, because most of the concepts and the technologies are fairly new, so we have to, as an industry leader with 100 billion turnover, invest some of that back. So you get quite a bit for free from IBM, believe it or not. Free courses, free technology awareness sessions and so on, free methods of exploring your data before we actually get into the execution phase, where typically people are buying technology and deploying it and so on. So there's a lot we can do to help, and a good example of the sort of things that I'm working on typically, but this varies by industry, and I'm covering all sorts of industries, people who make complex things basically, but this maturity model is a typical example where at the bottom level we're talking about collecting samples of data and exploring ideas with it. It doesn't cost anything, doesn't make you any money, but it's pretty well got to be done, and you can go up through the exploration phase, production, data collection phase and so on. I'd say examples of that would be people like Peugeot Citroën are somewhere between 3 and 4, and they've invested in the technology to start collecting and analysing and thinking about how to use that data, and then the optimization phase will kick off through the new year as they begin to sell business services based on data. Other companies are completely taking a different point of view. I think Tesla is probably, the guys who make this incredible electric car, probably the world leader in the technology in that space, are well into level 5. And then we've got some other clients, I shouldn't really name them because it might be embarrassing, but they're talking about possibly doing something on level 1. So just within the automotive arena, in brands that you're all very familiar with, there's an incredible disparity of progress up a maturity model. So I'd certainly say one of the things that we can do to help is discuss maturity models and use cases to help you in the specific industry that you're in actually figure out what the steps of this process would be, because there are decisions at every point in terms of investment, training and so on. So that's really all I had to say. Welcome any questions. Automotive, nice easy ones please. Any hard questions Anna can pick up on? Sounds like it's lunchtime then. Not a single question. Seems to be different in every company, but I'd certainly say, yeah, the question was really around the where do you start with various components like Hadoop, I suppose, is the part of that. So examples like General Motors, who already had a data warehouse and all of their IT infrastructure was already built to support ERPs, was to support CAD systems, was supporting customer databases, and nothing really to do with being a customer-centric, data-intensive company. It was a complete shock. So for those guys, the use of Hadoop was the quickest, easiest way of creating a landing zone. So all of this strange data that needs to be thrown into something, let's put it in the landing zone. Hadoop met the criteria for that. When you then look at the challenges of processing that data, although we can do it in Hadoop using big SQL, we can run Cognos queries directly into that. Some of the classes of analytics were so complex it justified the use of, in this case, an Netezza blade to actually optimize that particular query. And things like Insure the Box, whose challenge is to make the right offers to each customer each month, is based on those complex type of maths containers. So that's where the Netezza box fits in as an accelerator. But this idea of just saying, well, I'd start with a landing zone, because we know that we're going to have to deal with all data. In the automotive industry, the problem was, the cars are making 433 megabytes a minute. What are we going to do with the stuff? So that sort of solved that problem. Depends on your industry, really, but it seems to be my experience now that Hadoop can just be thrown in as a cheap way of solving the data landing zone problem. Thank you. Now is it lunchtime? No more? Thanks. Thank you.